everybody, in this video we'll talk about domain of a logarithmic function, advanced topics. So the first thing we need to talk about is this portion here. This portion's called our argument. It's inside, everything inside of those parentheses, and it must be greater than 0. Argument must be greater than 0. Remember, 3 is the base. What it's equal to is the exponent, and then this portion is the argument. So the 9 minus 4x needs to be greater than 0. Why can't it be equal to 0? Well, go ahead and type the log of 0 into your calculator and you'll see that's not a value, it's undefined. So after solving this, we get negative 4x is greater than negative 9. And then we divide by negative 4 on both sides. Remember, when you divide by a negative, when we are dealing with inequalities, then the sign flips. So it becomes x is less than 9/4. So how do we write x is less than 9/4 in interval notation? Well, we're going to go from negative infinity to 9/4 because that's everything less than 9/4. And then we're not going to include 9/4. So this is going to be the domain of our function of f. Okay, let's do another example. Okay, so again, our argument needs to be greater than 0. So this piece right here needs to be greater than 0. Okay, so everything inside is x squared minus 1 needs to be greater than 0. Which means we need a positive number, right? For our outputs. This factors into x minus 1 times x plus 1. Now, do you recall in the last chapter when we solved these polynomial inequalities? What did we find? We found critical values which were negative 1 and 1, and we found those by setting each of the factors equal to 0. And then we test points, right? So let's go ahead and test points in between these portions. And what do I want? I want it to be positive. Whatever my outcome is, I need it to be positive. So let's test negative 2. If x equals negative 2 and I plug it in, negative 2 minus 1 is negative, and then negative 2 plus 1 is negative. So I end up getting a positive. Okay, so I want this interval. What if I plug in negative 1? I'll get it that it's equal to 0, which I don't want, so I'm going to have an open circle there. If I plug in 0, 0 minus 1 is negative, 0 plus 1 is positive, so overall I get a negative, which I do not want. So I'm not going to include that interval. Now let's go ahead and plug x equals 2 in. 2 minus 1 is positive, and then 2 plus 1 is positive. So overall, I get a positive here. And this isn't negative 1, it's just negative. And I want a positive, so I'm going to include this portion and everything outside of those. And I don't want to include 1 because I will get 0. So what are my intervals that are going to make this argument greater than 0? Well, I'm going to go from negative infinity to negative 1, and then from 1 to infinity. Because anything else is going to give me a negative inside my argument or 0 inside my argument, which I can't have. Alright, let's do this problem type. What has to be greater than 0 when I'm talking about logarithmic functions? The argument, which in this case is a rational here. So x minus 2 over x plus 3 has to be greater than 0. What are my critical values I'm going to pick? Well, I pick where my denominator is equal to 0, which happens at negative 3. And then I pick my x-intercepts, which is going to happen at 2. If I plug in 2, I will get 0, so I'm not going to include 2. And then my vertical asymptotes are at negative 3, so I'm never going to cross negative 3. So far I have this. Now, let's go ahead and put some points in between these intervals. If I pick negative 4 minus 2 is negative. And then that will be divided by negative 4 plus 3, which is a negative. So overall, in this interval, I'm going to get a positive. Did I want a positive? I did. So I'm going to include this portion all the way to negative infinity. If I plug in 0, I'll get a negative over a positive, which is overall a negative. I don't want anything in that interval. If I plug x equals 3 into this piece, I will get a positive over a positive, which is overall positive divided by a positive is positive, which is what I want. So I'm going to go from 2 to infinity. So what's the interval that I can plug into my function? I can plug in any x value from negative infinity until negative 3. I can't plug in negative 3. But then I can plug in 2 all the way to infinity. If you need more help solving these inequalities, okay, then I do have more videos on solving rational inequalities or polynomial inequalities on my channel as well.